Dear students, welcome to Statics and Dynamics. Thank you for tuning in to this video. This is the second video of the first lecture, which is an introduction about the statics and dynamics and the description of what mechanics is, what are the units that we're going to be using, and what are the branches of mechanics. We stopped last time on the units of measurements. We were talking about the units. So we defined 4 fundamental physical quantities that we are going to continuously use in our statics and dynamics problems. And they are the length, mass, time, and forces. We discussed Newton's laws and specifically Newton's second law. We stopped on the units. So we said we need to have units to describe these physical quantities. The discussion will bring us to exploring what unit systems are available and which one are we going to use. Now, there are 2 main unit systems that we are going to be using in our class. So the first one is called the International System, and it's a French system, and actually it's a modern version of the metric system, which has received worldwide recognition, and it's called System International. So that's where the SI comes from. In this system, you have kilogram as the unit for measuring mass and Newton for measuring forces. The other system is the US Customary System. Another name to it is FPS, which is we measure length in feet, we measure force in pounds, and we measure time in seconds. That's where FPS comes from. So in the US Customary System, mass is measured in the unit called slug, and the force is measured in pounds. You can see in the slide a schematic representation of the 2 systems. Let's talk about the units in each system and how if we can map them together to get a better idea about what to use when. Table 1 shows the different units in each system. In the SI system, in the first row, you can see we have meters for length, second for time, kilograms for mass, and Newton for force. See with the aspect that Newton is a derived unit from the previous 3 units. Relying on Newton's second law, F equals mass times acceleration. We know that mass is a kilogram and the acceleration is meter per second square, and that's where we get the Newton as a unit for kilogram multiplied by meter divided by second square. If you look at the US Customary System, FPS, which is the feet, pound, second system, you know that we're measuring length in foot and time in second, and pound for the forces. And you can see that the slug, which is the mass unit, is the derived unit from the length, time, and force. So this is the different distinction between the 2 units. In the SI system, force is the derived unit. In the US Customary System, slug, which is mass, is the derived unit. To put this in context, slug is derived from F equals ma. So 1 slug is equal to the amount of the matter accelerated at 1 feet per second square when acted upon by a force of 1 pound. So that's how we define the slug. Let's move on to a relationship or the conversion between the 2 unit systems. I want you to keep something in your mind. If you have a problem and the problem units, the question units is SI system, you need to solve the problem accordingly. So you need to use the SI system units. If the problem was presented to you with the US Customary System, you need to solve the problem using the US Customary System. Work problems in the units given unless otherwise instructed by the problem or the example. So here it's a small table that gives you the conversions. Be consistent, that's my message. And you can convert between the 2 systems if you memorize these conversion formulas. Many times we're going to be using the SI system. So we have some rules for using the SI system. And these rules also apply to the US Customary System. But we will go to discuss them through the SI system. So what rules do we have that we should be following? So this is a list of rules. First, no plurals. So if you have a mass of 5 kilogram, you just put 5 kilogram without the S at the end. You need to separate the units with a dot. So if you have 2 different units, let's say meter multiplied by seconds, so you have to have the dot in between them, because if you did not, ms alone without the dot is going to give us the impression that this is microsecond. And that's not what we want to have. Also, most simples are in lowercase, but we have key exceptions. So Newton, Pascal, mega, and giga, they're capital letters. Also, exponential powers apply to units. So if you have centimeters multiplied by centimeters, you can write it as centimeters squared. Compound prefixes should not be used. So the final result should always be presented using a single prefix. That's very important. We have a table that show common prefixes that we're going to be discussing that's found on your textbook. So I'm sure that most of you are familiar, should be familiar with the prefixes that we use over and over in physics and chemistry. Keep in mind that in general and after calculations, it's best to keep numerical values between 0.1 and 1000. If it's less than 0.1 or more than 1000, you need to use a prefix. That's very good practice, and that's the engineering notation that we follow. And in our coming in-person session, we will discuss the engineering notation and what the role of the three significant figure that we're going to use in order to provide our final answers in the problems that we're going to be solving. So I hope this is a summary of rules that we need to follow, no matter what you're using, which system you're going to be using, SI or the US Customary System. Now, let's show some common prefixes used, and I'm sure that you all know about them. So if you have 10 to the power 9, this is giga, that's the prefix we should be using. If it's 1 million, it's mega. It's 1000, it's kilo. And this is if you have submultiple, it's milli, micro, and nano. 10 to the power -3, 10 to the power -6, and 10 to the power -9. So you should be aware of these things. We're going to talk about significant figures in the in-person session, and this is the number of significant figures. This determines the accuracy of the number or your result that you're providing, and we will talk about this a little bit more. We will going to use the engineering notation, as I mentioned, with something called three significant figures in our final answers, and we will solve problems during that in-person session. Also, please keep in mind there's something called something important about rounding off your results, rounding up or rounding down. So if you have we're going to talk about this also in the in-person session. So it's if you have and the rounding is the number that's more than 5 or less than 5 or equal to 5, we're going to discuss that, which is half. So this concludes the first lecture of the statics and dynamics, which is in the introduction and the general concepts that we need to provide, and this will set the stage for us to move ahead with the following topics. Thank you for watching, and till next time. Bye.